Hello, good morning.
Good morning, sir.
I hope you are not lost interest.
No, no, this
So how is your work going on?
work is kind of hectic, so I'm not able to attempt assignments.
Yeah.
Maybe that is the reason you're asking.
Yeah, yeah. And few of them remain absent, so
Maybe she needs to move to everyone.
it's only because of work pressure. Eh?
Yeah.
You are into development now?
Yes, sir, started.
Okay. So what is the domain in which you are working?
So it's a storage.
Okay. Okay.
So maintaining the data in the storage systems.
Okay.
And how do we protect? That is the technology what I'm working with.
Okay. So storage means a lot of storage structures you have to understand and
Yeah.
optimal way of putting that in place.
And also compressing and how do we use the data.
Okay.
And you don't need to have the mismatches in the data what you write to the disk. Yeah, there is one part what I'm working on, basically on protecting the data. How do you lock it and keep
Ah.
it intact?
All are working on the same domain or they have different assignments?
I think it's only me into this one, data protection. Vinod, Ashwini, they are all into a different
Okay.
technology.
Okay. Others will be joining?
Looks like, sir, maybe Ashwini can check.
Okay, just give a.
Oh, Vinod and Shilpa they have meeting
Oh,
10:30 to 11, I
okay.
think.
Shall we start then?
Yeah, Pooja is on leave.
Okay,
Nikita is
Pfizer I
joined.
joined.
Faisal has joined now.
Okay.
We can start, sir. Anyway, we are going to record it, right?
Yeah, yeah. So in my previous session, I covered linked list. It's an arrangement of nodes linked to one another, and we looked at how to append, how to add, how to insert nodes into the linked list. So what was remaining was how to delete a node. So given this single linked list pointed to by head, if suppose I want to delete item 5 in this linked list and call this delete node with int x with x equal to 5, so how would I carry out this operation? For this you require two pointers. One is previous pointer and another one is next pointer, or you can take it as t pointer, temporary pointer. So what you do is initially you start with t starting here, and before it you just have to check whether the element you are searching is at the head only. So then deleting that would be just moving the head by one step, that is head equal to head next. If you do that, number 7 gets deleted. So that's the special case. We'll consider that in the code. Now to delete 5, all that I have to do is traverse this pointer t till 5, that is until t arrow data not equal to x. You do t equal to t arrow next. So as you can see, t data is 7, not equal to 5, it will move here. Again t arrow data 3 not equal to 5, it will move here, and once it hits 5 it will stop here. But at the same time you should be taking one more pointer previous, which will follow the pointer t, that when t is at node 3, the previous will be pointing to its preceding node here, and now that t is pointing to 5, this previous pointer should be pointing to this particular node. Now, why this is required? Because to delete this particular node here, to delete this node, I have to alter the pointers. That is, I should make this previous arrow next point to t arrow next, so that this node is completely bypassed. That is, after deletion, node with value 3 will be pointing to node with value 1. It means the next of, assuming that pointer name is next here. So previous arrow next should be altered. Okay, so how do I change that? So if I do previous arrow next equal to t arrow next, see what happens. This pointer is removed from here and this will point here now, because t arrow next is this address and previous arrow next is this address. So effectively we have removed node pointed to by t. Now all that remains is just delete the pointer t. It means delete the object pointed to by t. So these are the only steps needed to delete an item from the linked list. Only thing is you have to traverse till the data containing value x, which is equal to 5 now, and then set previous next equal to t arrow next. So this will work for all nodes except the first node. In the case of first node, that is a special case. So if t arrow data is equal to head arrow data, then you just have to do head equal to head arrow next and again delete t. So this first node gets deleted. Okay, so we'll consider all these cases in one single method, delete node, in my implementation. So if you recall, we implemented singly linked list with all these other operations: insert node, add node, append node. Delete node was to be covered. So what I have to do is, again I declare node star t, which is equal to head. So let t point to the head, and you require one more pointer previous, which is not initialized anywhere. Now first step is, if t arrow data equal to head arrow data, it means you are deleting the first node only. Then all that you have to do is head equal to head arrow next and delete t, and from here you can straight away return. Okay, so if t arrow data not equal to head, it means the node you are trying to delete is somewhere in between. Then you have to set up a loop while t arrow data not equal to x. So before you move t to t arrow next, you have to save that in the previous pointer. That is, let previous pointer remember the current position of t. Then you move t equal to t arrow next. So what happens is, when you come out of this loop, if x is present in the linked list, t will be pointing to the node containing x and previous will be pointing to the node preceding to that. So now if t is not equal to null, what might happen is, if x is not there, t might reach the end of the linked list. So t not equal to null pointer, it means you have found a node which contains value x. So all that you have to do is, you make previous arrow next equal to t arrow next. Okay, so this will bypass the node containing value x, and now you have to delete the pointer t. Why delete? Because you have dynamically allocated space and it is your responsibility to deallocate the space. Okay, so if whenever you delete any node from the linked list, the delete operation has to be carried out by the programmer. Is this part clear?
Sir, once can you go back to that diagram, sir, you were explaining?
Yeah. Now here I can give a cout element not found. Yeah.
Sir, here initially 7 is pointing to head, right? The T, head of T.
T is pointing to head. Yeah.
T is pointing to the, so head of next is the pointer which is pointing to the 3.
3. Yeah.
Okay. Okay.
Suppose if you are deleting 7 only, then you just have to make head equal to head arrow next. So that head comes to node 3 and this 7 is pointed by T, you delete that.
Then we delete the head node.
Yeah, head node. But that is not the case if x is equal to 5. So then you have to traverse the linked list until you locate the element with pointer T, and the previous pointer is just following T one step behind.
Okay.
So T previous arrow next is equal to T arrow next will bypass this node, and now this T pointing to 5 can be deleted.
Okay. Okay.
So now,
Okay, sir.
so let's see if everything works fine. Now in the main, I have already inserted all these elements. Now if I want to delete something from the list dot delete node. Now there is 5, 7 and all. Let me delete this 7 only. And after that again display. So let's see what happens. Okay, so 3, 7, 5 was there. We appended 11 and then we also inserted 9. So this was the list. Now we deleted 7, right? Oh, what went wrong?
3 is deleted, right?
Why 3 got deleted? I am saying delete 7. T arrow data. Oh, it is not T arrow data. It is x equal to, isn't it? Head arrow data equal to x. You should compare with value x, isn't it? So the first condition was becoming true. So compare whether head contains x. So then you have a special case. Otherwise, you traverse the list until you find x and then delete. So that was the mistake. Let's see now whether 7 gets deleted from the list. So as you can see, 3, 7, 5, 9, 11 are there and 7 is deleted. Now after 3, it will point to 5. So 3, 5, 9, 11. Is this deletion part clear?
Yes, sir. Can we try, sir?
Yeah, you try. You understood the mistake? No, I was comparing head with itself, so this was matching, so it was deleting.
Yes, sir.
Yeah, so head arrow data should be compared with X. You want me to check whether
maybe
handles the
2
case?
or something
Yeah.
which is not there. Doesn't do anything.
It didn't do anything. It should have displayed element not found actually.
Yeah, maybe we could handle that.
So that part you have to take care and see whether it handles the first case. That is, if I remove
it is handled.
First is it's removing first one, no?
Yes. First also it's removing, last also it's removing.
Okay. So we could implement a linked list which has these different operations. Now how do I make it generic? That is, now it is going to work only for integer values. So can I make it generic? So that's the next thing we should look at. So can you tell me how to go about doing it?
Template.
Yeah. Then?
Type FT.
Yeah. Type name. Okay. So where all I should make changes?
In the data, yeah. T data. And then in node index. Should be T.
Right?
Yeah.
Okay, now this pointer should also be of generic type. isn't it? Because it will point to a generic node. So this also should be again template type name. Same type. So here head should be of type T, and when you want to add, it should be of type T, and any new node that you generate should be of generic type. So that if you put a string, it should be of that type. Likewise, okay, append again T here. This should be T. Insert node, here again it should be both should be of type T.
Even node.
So you'll realize how useful the template concept is. With just few changes you can make it generic, and it will work for all data type. There is one more here. Okay, now it should be int type. So this is work. This will work as before. Suppose if I create one more. Linked list string names dot add name. So we'll add few names to the list. Okay, so let me see if it displays. Okay, so the last one which we added has come first. 3 names are added, so it should work with append and other things.
So for both the classes we're giving template name as T, right? We could still use different template name.
No, that would be problem, because linked list contains nodes of type node.
Second class is inheriting from the first one.
No, it's not inheriting, but see, if you make this template type T different, then head cannot point to another type, no? It has to point to the same type. Node containing type T. So the data type has to be same, isn't it?
Okay.
So other things work as usual, you can just verify that. But just see how easy it is to convert one class into generic and use it to work with any data type. You don't have to rewrite the code. Okay. Now coming to doubly linked list. One problem with singly linked list is you cannot traverse the list in both the directions. If you start traversing forward, you can go in the only forward direction. Okay. So doubly linked list where you have 2 pointers with each node, previous node and next. Okay, so you can traverse in both directions, that is the advantage. And Only thing is you have to add one more pointer to the node class that you have defined. So previous pointer should be also added. So as you can see, the new node when you create, it will contain the data part, the previous pointer and the next pointer. Okay. So if you observe this linked list, head will point to a node containing two pointers. Previous, the head node will not point anywhere, so it is null. But the next of it points to the next node, which is value 3. And the previous of node 3 will point to node containing 7. Okay. And the next of 3 will point to null. So this is the existing linked list. Okay. Now if I want to append a node or add a node to an existing list, if head points to null, then you just have to say head equal to new node. Isn't it? So if you just do this, first node will come up. If you want to add a node, that is adding a node at the beginning of the list, you have to create a new node pointed to by this. And now, first thing is new node arrow next should be equal to head. All of you agree? What happens when I do this? New node arrow next, this will point to where head is pointing. Correct? And head should now become new node. So what happens? This head will move here. The previous of this is null, but the previous of this node should point to the head node. So that also must be done. So before I do this step, head arrow previous should be equal to new node. Okay, there are three steps here: new node arrow next equal to head, head previous equal to new node, and head equal to new node. So what happens is this will point to the previous node. Do you follow this? Or we have some?
So this is adding a new node to the beginning of the list.
Pardon?
This is adding a new
This is
node to the
adding
beginning
a
of the
node
list.
to the beginning of the list. How to add at the end we shall see later. If you want to append, then again use the pointer T, take it till the last node, and then T arrow next will become new node, and new node previous will become T, like that. So few steps have to be done. This much is
But
clear?
what is different here from a single linked list to double?
Yeah, see, there are three steps here. T arrow next equal to head, and head arrow previous equal to new node, and head equal to new node. So one extra step will come here. Head arrow previous should be set to new node. No? Similarly, when you append, let me show you that append part also, append mode, which is here. So let us say we have another node here. So when you create a new node, it is pointed to by new node. Let us say 11, and its previous is null, next is also null. And you have to take a pointer T and T equal to T arrow next until you go to the last node. Until T arrow next not equal to null, you have to say T equal to T arrow next. Put this in a while loop. Okay, so when you come out of this loop, T will be here. Now what all changes I have to make to append this new node? So first step is T arrow next equal to new node. So what happens? This null this will point to new node, correct? And new node previous should point to T, so that this points here.
Okay.
Correct. Is that all? Yeah, that's all. Okay, now you see the new, only these steps are required. T arrow next equal to new node arrow previous equal to T. This is previous, this is next. That next new node next is already null. So these are the two changes you have to make to append. But when
So
you
when the
want,
next pointer is pointing bidirectional here, right?
yeah,
What I mean, with the single pointer also, we should be able to traverse and access all
yeah. Now this T, if I want to take it back to head, all that I have to do is while T not equal to head, T equal to T arrow previous. Correct? This will go back to this node, then its previous will go back to this node, and once it hits head, it will stop. Okay, so you can traverse in both the directions. That's the advantage. Okay, so we shall see the implementation of add and append.
Okay.
Okay, so what all changes I have to make to this node? So in singly linked list node we had only next. So I will add one more node star previous. That also should be set to null. Okay. And in doubly linked list I have to create star head. And in the public part of it, doubly linked list and pointing to null. Then the constructor of this head will point to null. Now we need to add the methods. Add node. Okay. So the first thing is if head equal to null pointer, we have to do something, and if not, we have to do something else. So what I have to do is first thing create a new node here. Value x. So both this is a new node creation with next previous set to null. As you can see, the constructor of the class node will be called, and the next previous of this new node will become null. And if head is null pointer, all that we have to do is head equal to new node. Nothing else, isn't it? Because that is the only node. The previous of the head will be null, next will be null, because that is the only node that we will have now. Okay, but if head is not equal to null, it means there are already existing nodes. So you have to add the node at the beginning of the list. So for this, what all you have to do? New node arrow next equal to head. So this will point to the head node, and head arrow previous should point to new node, and this new node should become head node. So head equal to new node. So 3 steps are required. This part is clear? Okay. And display is same, void display node star t equal to head while t not equal to null pointer, cout t arrow data little space. So this will display the list in the forward direction. So let's see whether this works. So doubly linked list dlist dot add node dlist dot add node dlist add node, okay, and then dlist dot display. So 5 should come first and then 3 then 9. What happened? I think so we missed the terminating condition. Dlist. Okay, so here in the while loop I did not move the pointer, so it was printing 5 all the time. So t equal to t arrow next should happen, right? And 5 3 9. Now can I display this linked list in the reverse order? So let's say reverse display. So again I have to take node star t equal to head, while now you should not go till the null pointer, you should go till the last node. So that condition is t arrow next not equal to null pointer, t equal to t arrow next. So this will take you to the last node. Now to display this, while t arrow t not equal to head, cout t arrow data and t equal to t arrow previous, isn't it? So in the first while loop I am going till the last node, and then in the second loop I am traversing back till I reach the head node. Now one problem is t arrow head, when it becomes equal to, it will not display the head node, right? So again you can say t not equal to null pointer, because you are going in the previous direction. No, the previous pointer of the head will be null. So t arrow not equal to null pointer, t not equal to null pointer will ensure that the head node will also be displayed. So when I call this reverse display, 9 3 5 should be displayed. So let's see. After this I will do a cout reverse list. The list dot reverse display. Right? 539 935. So I could traverse in both the direction. This was not possible in single linked list. So would you like to try this out?
Yes, sir.
Okay. So just let's go in small steps so that you get acquainted with the code syntax here. And then we shall see how to append and how to insert all that. Done?
Yes, sir.
Okay. So let's see one last thing, that how to append the node at the end of the linked list. So I append node index. So I need to go till the end of the linked list, the last node, and then append at the end. So for that I have to take one temporary pointer which will point to head initially. Then while t arrow next not equal to null pointer, t equal to t arrow next. And then, yeah, now I have to create a new node, star new node. Now first thing is I have to attach this node. T arrow next should point to and new node arrow previous should point to T. Am I right? That is all that is needed to be done if you want to append. Now again, initially if head is null, that special case you have to take care. Okay. So here you can append with empty list also. No? So if head equal to null pointer, then head equal to this new should be, take it here. And once you do this, you don't have to do rest of this, you just have to return from here. If head is not equal to null pointer, then you have to traverse till the end, and at the end you have to append a node. That's all. So here to the existing list after 5, if I want to append something, I will do that here. Dlist dot append node 22. So what should happen here? After 9, 22 should be added, and in the reverse list 22 should come first. Okay, so 22 is appended, and when you reverse list 22, 9, 3, 5 is displayed. So this is appending at the end of the list. You note this also. So to summarize, doubly linked list has 3 parts in its node: the data part and 2 pointers. One is next pointer, another one is previous pointer. And today we saw how to implement a doubly linked list. The advantage here is you can traverse in both the directions. So that is how I demonstrated how to traverse the list in the reverse direction and list the elements in the reverse order. Right. And the operations of add, append require slightly more complex logic to take care of the previous pointers and the next pointers. So in the next class we shall see how to insert a new node in between. So that part we shall explore next time, and also convert this into a generic class so that data of any type can be inserted in the doubly linked list. Alright, so we shall close for today.
Sir, thank you, sir.
Yeah.
Sir, if you don't mind, can you explain me with a diagram? I'll join bit later.